A warm welcome to everyone. Thanks for your time. Thanks for being on time. It's nice to see all participants being there to this web exchange, one from GGI. This is the first of many web exchange that will be organized by Gulf Glass Industries. Gulf Glass Industries, to those who have not known Gulf Glass Industries, we are known as GGI. We have been here in this business for 30 years now. Next year, we will be celebrating 30 years of existence in this leading market. Uh, we are one of the leading glass processors in the industry. My name is Pascal De Silva. I have been working in the glazing industry for nearly 22 years. And out of those 22 years, I have spent 18 years with GGI in learning more about glass and building up my experience. So why web exchange? Why not webinar? Is because at GGI, we want to share the experiences that we have with the community, with the glazing experts, with our colleagues, with our competitors, with people, architects, and all the parties who are involved in this sessions. We believe in GGI. There's always a better way. There's always more to learn, and no one has all the answers. So we believe what we are presenting is not the best way, but there might be much better ways we can approach to solutions. So with that, we will be starting this web exchange. And again, a warm welcome to everyone. So what is the topic today? Is beauty without a flaw. The flow will be a 25 to 20 minutes presentation. We will have a 5 minutes chat answering. You can type in your concerns or any messages which are on your chat, and we will have a 5 minutes look at all that we can cover in that 5 minutes. So let's see why beauty without a flaw. Glass. Before we talk about glass, there are some things that we need to know is that beauty without flaw is unnatural. Everything that is beautiful has a flaw in it, and everything has inherent flaws. And glass is not an exception. Glass is a beauty like no other material. James Carpenter, one of the design associates in the US, has this to say: I look at glass as a material that is capable of revealing light through its wide-ranging material properties: transmission, reflection, refraction, and diffusion. It has a special ability to surprise, delight, and engage us with our environment in a way that no other material can quite achieve. And that is so true about glass. It is a beautiful material like no other material. So coming to understanding what is that flaw in this beautiful material, we need to know the definitions to understand what is that flaw. We hear these definitions of spontaneous fracture and cracks in glasses. A spontaneous fracture is something which is unexplained but noticeable breakages of thermally treated, in bracket, fully toughened or heat strengthened, which have been labeled as spontaneous fractures. On the other hand, cracks are breakages in any other types of glasses, which may be annealed glass, which are not heat treated, and they are referred as to cracks. But within the industry, we have some misleading definitions and information regarding spontaneous glass fractures or breakages. We say that spontaneous glass breakage is a phenomena by which glass may spontaneously break without any apparent reason. And as glass industry experts, we need to clarify these definitions. Glass will break for a reason, because there's some reason. It cannot break without any apparent reason. And so there's always a reason. There's always a reason for glass breakage. Glass may fracture and crack from a variety of causes. They may be as edge damage, which can be caused by sharp body impact, poor glazing design, poor workmanship, inferior glazing materials. The other thing where the reason for breakages is excessive load, mechanical loads, and thermal stress. Last but not the least is inclusion in the glass. There's always a reason for glass breakage. Sometimes it is easily diagnosed by looking at it, but sometimes it needs experience and expert opinions or expert people to look at it and analyze it. So let's look at where we start with. One of the major reasons for glass breakages in our experience, and we have been collecting data as GGI, we have been collecting data since 2005. And most of the damages, edge damages, are the main reason for spontaneous breakage of glass. The edge damage reduces the strength of the glass by nearly 50%, and this increases the likelihood of breakage due to mechanical or thermal stress. These edge damages can happen during manufacture, that is processing, transportation, installation, and service conditions. One of the things that you see in this picture is edge damage. And this was a project which was uh, completed in 2018, and we were called on the site saying there's spontaneous breakages of glasses. There were nearly 35 pieces of glasses broken within 6 months in 2019, after 1 year after the opening of the building. And so when we went there were glasses which were broken. And when we did an investigation, we only seen edge damages. And through this edge damages, the glasses were propagating the cracks and leading to glass breakages. And it was happening only on one side of the elevation, is because that elevation was getting the most of the temperature, most of the sunlight, and also the wind. Along with that, the pillowing effect of the glass, which you can see in IGU, which keeps on moving. It's like the unit keeps on breathing, and you would find that the cracks would just penetrate and get into the tension zone, which we will look into it later. So this job was nearly 20,000 square meters of heat strengthened glass, and we had a lot of breakages on the heat strengthened glasses. But the inner one, tempered glass, which was another 20,000 square meters, we did not have any spontaneous breakage on this building. So that shows us that edge damage is one of the key reasons where we can find breakages. There's always a reason, as I said, edge damage. There's a hard impact or sharp impacts. Again, this can happen during installation and service conditions. We have always seen that one of the things that we
Spontaneous
have seen
breakage.
nowadays is that glasses are being used as balustrades. Single monolithic glasses are being used as balustrades. And it is elegant, it is beautiful because people tend to use it, glass as a beautiful material. And so there are no cover caps on it or there are no handrails on it, and what we call as exposed edge or frameless glass balustrades. But there is a concern because when you are using these glasses, there's always a possibility that edges can get damaged. And rightfully, the UAE Life and Safety Code 2018 is one of the few codes that have made it mandatory, at least in the UAE, that balustrade glasses have to be laminated because it is a barrier. And if that barrier breaks, there's quite a possibility that there might be a fatality on an accident or even a death if person falls off. So these are some of the things. Yet we see a lot of people using single monolithic, be it 19 or 12 glasses as balustrades in their buildings. But it has to be looked up by designers and architects and consultants very closely. There's also a reason of surface damage, poor workmanship. You can see that the scaffoldings put across the glass where damages the glass. The other picture that you see is scratches which are caused by cleaning when the building is given as a handover. They hand over the building and people try to use metal scrapers and scratches, and these scratches will not break the glass immediately. It takes some time. It can be 6 months, it can be even 1 year or 2 years that you would see at one point of time that the glass would experience breakages. This is the way that we see things on the site. These are some of the examples that we have seen people using metallic scrapers to clean glasses. The other concern that we have seen is, and we have experienced is, concrete slurry and construction materials that fall on the glass surface. And these are not being taken, the glass is not been protected. And this creates a surface damage. And this surface damage, in 2006, we completed a job of nearly 30,000 square meters. And by by the time the building was ready for handover, we had 400 units of heat strengthened glass broken spontaneously. So when we were called for investigation, we went and we investigated the whole building, and what we could find is the surface damages. There were there was something like this. The surface damage, this is under a microscope, which is nearly 10 times magnification, and you can actually see a spot. You can actually see the surface being damaged. And from this point, the glass would crack. When we went and investigated more into it, we understood that after the glazing was done, this 30,000 square meter of glass, which was put up on the building, on the top floor, they were doing some concrete work, and the glass was taking in this concrete. It was just falling onto the surface of the stone and the concrete. Everything was coming down with such high velocity and hitting the glass and creating these cracks. Not instantly glass breakages, but after a few months. And this was during the summer month in the Middle East. And it gets too hot, and you could see that we had 400 units breakages just because of the surface damage. So this is another reason where we have surface damage causing glass breakages. The other reason for glass breakages is poor glazing design. People are using rotules and spider fittings and metal fittings a lot, but not having a cushion, not having a separation in between can cause such breakages. This glass was installed, and within a year we had glass breakages seen on this building. And when we investigated, when we opened the spider fittings, there was no separation material, there was a metal to glass contact. The other picture that you see is where there is a contact between the glass and the metal. And designers today, or probably designers today, are taking that extra effort to keep a clearance and use setting blocks of the right hardness. But probably on fabrication and on site installation, this has to be looked at, because we are seeing an increase of such breakages for the past 3 years or 3 to 4 years, where we are seeing a metal to glass contact. And everybody is saying the glass is broken without any reason. It is spontaneous breakage. It is not. There is a reason for it, because these guidelines have not been followed. A very good handbook is the Ghana glazing guidelines and the GGF glazing guidelines, which can be actually seen on the public domain. You can visit sites and actually find a lot about setting blocks, about edge clearances between glass and metal. Coming back to the other reason, there's always a reason, an inferior glazing material. As I said, exposed edge glazing, frameless, nobody wants to see a metal around the glass. And so people have started using grouts. The cement grouts that have been used for a long time, but they have compatibility issues. So people have started using epoxy grout. Now, having known that, we had two instances where we have seen that the glass breakage, spontaneous breakage, we had a high wind load conditions where it broke nearly 40 units within 3 days, balustrade glasses. And we were called and then said, the glass is breaking, spontaneous tempered glass. And it is a spontaneous breakage, broken without any apparent reason. That's what the customers always tend to say. And during investigation, we found out that the grout material that was being used was too stiff, and the hardness, it did not allow the glass to move in that pocket. It was not able to breathe inside that. The coefficient of expansion between glass and the metal and the grout needs to be considered. Glass has to have some expansion because the building movement and the material movement will create such breakages. As you can see, most of the breakages were like this, and the grout was changed, and a wet glazing system was used to change it. The change in the grout, the right grout. There are grouts which are specifically designed for glass balustrades, and that has to be taken care of. There's always a reason, and excessive loads or mechanical or thermal loads. Now, this is not a design on the glass, it's not a printing, but this is how the glass was when we went, because there were glass breakages and they were breaking from the rotules or the spider joints or the whole area. And this was a condition where water and there was continuous uh, load on the glass with all this dust and all this sand which was there on the glass. So it was a constant load on the glass. So these need to be checked as how closer the designs of having holes around the corners, how far it should be. Will it be able to take that loads, the maintenance load and then the service loads. This is the glass, how it looked from below. And we had breakages, and it were all originating from the rotule joints. So this is some of the things that we have seen, and we are sharing the
Yeah.
experiences so that we understand that just spontaneous breakage, people say it's glass problem. I believe it is more than that. There's always a reason, and thermal
1
stress in
million, 1
anneal
million
floored glass is one of the reasons. The pictures that you see is a courtesy by Vitro, formerly PPG. They have a very good presentation on this, and I have taken some of it. The breakages that you see in anneal glass is one of the reasons people are shying away, or designers are not using anneal glass, is because they fear of thermal stress breakage, likely due to edge damage and the thermal gradient that can happen in anneal glass. You can look at the glass and you can actually find out whether it is a low stress thermal break, because the origin will start from the edge of the glass and it will only have probably one crack along the glass. So this is how it looks. But having said that, this is the high stress thermal break. And this can happen due to only thermal variation, thermal gradients that can happen. Many a times, what happens to the glass is the edge of the glass, which is in the framing, heavy framing, cools, remains cools, and the center of the glass is heated up because of the sun's exposure. And there's a temperature difference. Now, in service conditions, what we have seen is any temperature difference between the edge and the center of the glass, about 40 degrees centigrade, can create such high stress breakages. You don't have to do thermal stress analysis on tempered glass or heat strengthened glass, because tempered and heat strengthened glass can take a temperature difference between the edge to the center of approximately 250 degrees centigrade, which is never going to happen on a building in such conditions. Having said that, we have seen glasses, annealed glass. We have used in two projects nearly 60,000 square meters of annealed laminated glasses. It's been nearly 10 years that the project is in service, and we do not have any thermal stress breakages. It is a matter, and the outer glass, to be precise, was a heat strengthened glass, high performance, double silver glass. So, if the analysis had been done correctly, thermal stress analysis have been done correctly, you can use annealed glass on buildings. And this is used in the Middle East. And it is perfectly okay. So architects and architects should, or probably the designers should look at it, because one of the thing is eliminating totally the risk of spontaneous breakages can be taken out by using annealed glass. Not only that, distortion issues are taken care of. Apart from that, you do not have issues like delamination that can happen on tempered glasses, laminated glasses. So annealed glass has to be looked at, and we feel that annealed glass lamination is quite an advantage to look at glass breakages. There's always a reason, and we will come to the inclusion in glasses. Now, inclusion in glasses is a very hot topic, and I have taken much of this from PPG and Saint Gobain, Vitro and Saint Gobain glass. Any undesirable material embedded in glass is considered as an inclusion. Now, having said that, glass has many inclusions, shapes and sizes, the distribution density is given. You have international standards such as ASTM 1036 and EN 572. You can have a look at it. There are inclusions which are allowed in the glass of 0.3 mm, even to 0.5 mm. Having said that, any inclusion of bubble greater than 500 microns, 99.9% is been deleted or detected by the online inspection and then removed off onto the float glass production. The issue is nickel sulfide inclusion greater than 50 microns can create special problems. Detecting such inclusions is difficult on the line. No matter what people say, having detectors on the line, you cannot detect such small inclusions very easily. And so elimination approach is better. And we will get into these discussions in our next web exchange, which is part two. We will continue with that discussion. Glass manufacturers are doing everything. They are building up their lines, the float lines, and to minimize any inclusion. So there's a lot been done, and we will touch on that topic in the next sessions, which we'll be doing. Butterfly pattern or H shape. Many people in the industry look at the glass and they say, wow, that's butterfly pattern, that's a H shape. And eureka, they have found it. Oh, this is spontaneous breakage, this is nickel sulfide breakage. That is not a right approach. Everything that is having a butterfly pattern does not indicate that it is an inclusion breakage or nickel sulfide breakage, because glass can break due to load, concentrated load, as the same way as you said. This glass, which is taken from Saint Gobain articles, is, and we have done our experiments and our exercises, and when we see that the glass is at concentrate loaded and broken, you will have a butterfly pattern. So even a soft body impact, even the EN 12600, if anybody is doing that, breaking the glass by EN 12600 or ANSI Z97, you will see a butterfly pattern on the laminated glass of a tempered or even a heat strengthened glass. It shows you a 8 pattern. So what should we do when we see something like this? At GGI, we pick up the glass, we try to analyze it. This is a 25 magnification microscope that we use to identify if there is an inclusion in that butterfly pattern. And what we found is these are just two of the photographs that we have taken from this microscope of 25 magnification. You can actually see one of the inclusion is shiny and the other one is probably dark brown or gold appearance inclusion. Can we tell that it is a nickel sulfide inclusion? As GGI, we do not say that it is an inclusion and we do not comment on it. We say it is a possibility that it could be a nickel sulfide inclusion, but we are not sure. How can we be sure? Is by doing an analysis, a laboratory testing to conclude the characteristics of inclusion. So SEM analysis has to be done. They are to be done in a laboratory, and EDS, which is pinpointing the analysis. As you can see from the graph, this is one of the inclusions that was sent to a lab in Europe, and they did the scanning of it. And you can see the peaks which are there, which show that it is a nickel sulfide inclusion. So that's the way that you can 100% claim that it is a nickel sulfide inclusion. Nickel sulfide inclusion breakages are not new. The first one to acknowledge nickel sulfide inclusion as a problem was PPG in 1940s. 1961, there was a paper published, fracture of toughened glass wall claddings. Uh, this was in respect to what happened in Australia. 1981, a Journal of Material Science, M.V. Swain, and then Dr. Andreas Kasper of St. Gobain, along with other glass manufacturers, have done quite a good work in understanding and providing solutions of how to minimize the occurrence of spontaneous breakage is due to nickel sulfide. The last development that has happened is EN14179 2018, which is the latest development in terms of holding temperatures and ensuring that the heat soaking is done properly. So it is not something new. There are a lot of things that we need to understand as we are in this region. What we have seen, and we will discuss this in the next uh, web exchange, is the why do we see so many glasses broken as nickel sulfide or spontaneous breakages in this region, is because the quantity of tempered glass that has been used has exponentially increased in this region. We have seen people using, instead of even in the inner glass, inner tempered laminated glasses we are using, instead of just using maybe probably a heat strengthened glass just for impact resistance, a lot of people are using tempered laminated glasses. So the number of tempered glass that we use, the other thing is the weather and the seasonal conditions, which we need to understand. The third thing is processing. Yes, there is that we will discuss in detail in the next web exchange. And it's time. If anybody has any chats, any questions, be free to do that. We have another 5 minutes to do that. So, so if there's any questions, you can put it across on the web chat. Somebody asks us the question, how at GGI are we controlling NIS breakages? As I said, it is a discussion that we would be touching in the next web exchange, and we would definitely let you know how we are doing it and what are the limitations on these things, as how much we can. As I said, elimination is not a possibility. Uh, it is minimizing the impact of breakages, spontaneous breakages in tempered glass. If you want to eliminate it, it all depends upon the type of glass and the uh, conditions. How is it better to use annealed glass than tempered glass? How is it better? Annealed glass is, as I said, it does not have the tendency to show spontaneous breakages, and it also can be used in internal locations where you have just an impact requirement and it can be laminated. As a single glass, no, I wouldn't suggest using single glass annealed glass, but laminated annealed glass is perfect. So, yeah, I'm. Uh, I will just we have to close the meeting because the questions I would there's one more question is asked is before we close is when did tempered glass start to be more used uh, than heat strengthening? If there's less distortion in glass with heat strengthened, then why do we need to temper? That is another discussion, but yes, it all depends upon the application, but it can be used. Somebody said, yes, tempered glass is stronger than annealed glass. Of course, it is stronger than annealed glass. But in situ, where we spoke about 60,000 square meters of glass being used on a building, the sizes were 4.5 by 1.8 to 2 meters. It depends upon the thickness of glass that you are using and what application. If it is for internal building, the inner pane of an IGU, then you do not have to meet the requirement because all your wind load requirement are taken care by the external glass where it is taking the whole load. But as I said, it is something that you would need to discuss with glass manufacturers and designers to do that. With that, I think I will share my email. If there are any other questions, any other clarification, we could do it across. I'm always available. You can send me your emails, and I would definitely try to answer it to the best of my ability. As I said, uh, it is that our solutions are not the best solution, or what we say is the not. It is a matter of exchanging views. It is a matter of exchanging and doing the best way how we can. So this is how we are. Thank you very much for joining us, and hopefully we will join again for the next presentation on more about nickel sulfide and spontaneous breakages.